Today's presentation is going to focus on design without boundaries in a multi-CAD world. My name's Kevin Grayson. I'm a Solid Edge technical consultant with Siemens PLM software. As a Solid Edge customer, you probably find yourself in one of the three scenarios listed here. Is your company a Solid Edge only company where all your legacy and current design data is in Solid Edge? Or maybe you're a Solid Edge company but you have legacy data in one or more other CAD file formats. Or maybe you're a multi-CAD company where your legacy and current design data is in various CAD formats. Regardless of which scenario that you're in, Solid Edge does a great job of managing multi-CAD design. Even if you're one of the companies who is a Solid Edge only company, you may find yourself using data from a customer or a vendor that's in another CAD file format. The value that Solid Edge brings is it allows you to accelerate your design by reusing data from multiple CAD sources to design, visualize, and validate your assemblies. What we're going to do today is we're going to focus on Solid Edge and how well Solid Edge works with the other guys, whether it's NX, CATIA, SolidWorks, Pro-E, Inventor, or even AutoCAD from a 2D perspective. Solid Edge allows you to bring data in from any of these CAD sources and work with it very well. Make changes to it if necessary and complete your design very, very quickly. In a typical day in the life scenario of a design engineer, they may focus on one or more of the items that you see listed on the left-hand side. Today we're going to focus primarily on assembly design, data reuse, and validation. Oftentimes when you're working with imported data from other CAD systems, you're going to run into issues where things may not fit properly or maybe things aren't working the way that you anticipate. So today what I want to do is focus on how we can assemble components efficiently, how we can add assembly intelligence quickly to imported data, create smart features at any level of the design, whether we're working in a single part file or at the assembly level, and then also how we can make flexible design changes at any level. Again, whether I'm working in a single part or working at the assembly level, Solid Edge does a great job of doing all of these different things. Let's take a look at what Solid Edge is capable of when it comes to working with data that's imported from other CAD systems. We're going to utilize this racing motorcycle as our example today. The scenario that we're going to run through is that we are a Solid Edge customer. We have a lot of Solid Edge data today that we've created, but we're running into a situation where we want to reuse data from our previous CAD system. The specific CAD system doesn't really matter. The example we're going to use today is going to be SolidWorks data, but it could have come from Inventor, Pro Engineer, NX, really doesn't matter. So I'm going to go ahead and turn off some of these outer components initially. Let's maybe just look at the frame by itself. And what we're going to do is focus here on the back end of the motorcycle where we want to connect our shock to the frame and then back here to the swing arm. And we have a mechanism that we designed previously. We want to go ahead, as I mentioned before, and reuse that data. So I'm going to go straight to our file open dialog inside of Solid Edge. And as you may have seen in your work today, if you go to File Open and go to the file formats, we can open up all of these different CAD tools. So as we look down here through the list, in this example I just want to find the SolidWorks assembly file. So again, notice for many of these CAD tools we can open up not only the single parts but also the assembly files. We're going to go to our file system here, go to our legacy files area. We have a SolidWorks connector is what we've called this, and it's referenced here. And I just simply select the SolidWorks assembly file and hit open, and that's going to open it up into the Solid Edge assembly environment. And if you look not only graphically but also in the Pathfinder, all of the structure of the assembly file comes across seamlessly into Solid Edge. So not only do we have single part files, for example the housing that we see here, and maybe this connecting arm or connecting component, but all of the other files that you see here, as well as subassemblies. So if I expand the subassembly, it also has the different file components within that subassembly. So the structure that, from the other CAD system comes across very well into Solid Edge. Now what I don't necessarily like is kind of the look and feel for how it came in from the other CAD tool, and that's okay because I can utilize the Solid Edge face styles to change how these parts look now that I'm working with them inside of Solid Edge. Before I do that, let's go ahead and save this, and again we'll save this to disk. It then becomes a Solid Edge assembly file. And we'll go through and we'll start changing the appearance of these parts and maybe make them look a little bit more realistic. There's some nice tools in Solid Edge to select components that exist multiple times. For example, I may select a part. We have a nice option here called Select All Identical Parts. That'll select all of those components at the same time, and then I can change their face style, make them look, maybe change their color. We'll do the same thing here for the bearings. Select all identical components. There are 6 of those, and maybe we'll change those to a steel face style. And again, if I zoom in on that, you'll be able to see it's got a nice little texture there applied to the steel face style. Maybe back here, if I recall in our top level assembly, it seemed as though our hardware had more of a chrome finish, so we'll go ahead and apply that. Now you can apply the face styles here at the assembly level, or if you wanted to go into the individual parts and utilize either the material table or part painter. I can go into part painter as an example and say, well, I just want to change maybe in this example the faces of my screw, and I can just select certain faces and maybe just continue to show that it has thread on the end. The other nice little thing about this is kind of a tip or a trick, is I'm not currently working inside of the screw part file, but I can bypass going back up to the assembly and go directly to another part just by simply double clicking on it over here in the Pathfinder. So if I want to go straight to this component here, if I double click on it, it essentially bypasses the assembly and then goes directly into that part, which is a nice time saver. Maybe we'll change this component to an aluminum face style. So we'll change that here. And then we'll go directly to the other component here, part 502. We'll just double click on that and basically do the same thing that we just did for this other part. And we'll change that face style. And again, that gives us some better look to the assembly that we just brought in. It looks a lot nicer than the way it came in originally. So again, we'll just save that. So now what we want to do is just go in, again we just opened it up, we want to reuse this data, and let's check and see how we can utilize that inside of our motorcycle assembly. So we will go ahead and edit into the frame assembly where some of these other components reside, and what I want to do is just find that in my library. Another little tidbit here is there's an area here called Open Documents. So if I'm a user who likes to have multiple files open at the same time, I can very easily just go to Open Documents and then find another document that's open, and I can just place that into the assembly very quickly. So what I want to do also is reorient this assembly to how it's going to be positioned in my assembly. I can do that easily just by holding my Control key down and just moving it around, and I can get it closer to the orientation it's going to be in. And then again, just very simply utilizing normal assembly tools like Flash Fit, I just start tagging geometry for how I want it to be placed inside of the assembly. So we'll place this maybe between these two members of our frame. We'll place it onto that component, and let's just go ahead and push that in just a little bit more, center it between those frame components. We'll assemble it up there onto the shock, and then the last thing we'll do is we'll just assemble it down here onto the swing arm. And you'll notice how all those parts adjust themselves as we are assembling the part that we just brought in. Now, What I may also want to do is I just fully constrained this, I'll call it the mechanism that we just brought in from SolidWorks. But what I want to do is, as I'm checking or validating how this mechanism is going to work, and as I'm moving some of these outside components in their range of motion, I may also want my mechanism to be able to move in its range of motion. So Solid Edge has a really nice tool here called Adjustable Assembly, and that will allow that mechanism to be free to move in its range of motion as it sits here at a higher level assembly. So let's check let's validate if this is going to work properly. So really all I'm going to do is utilize our drag component command, and we're going to check the minimum and maximum stroke of the shock. And as I'm moving the shock, we're noticing that our mechanism components are kind of falling apart, which is not good. And I'm going to assume that most of you who are looking at this presentation today have probably dealt with a similar situation. You bring in data from another CAD system. You need to check moving parts maybe inside of your assembly. You go to move some parts around and your assembly file just essentially blows up, or parts kind of just fall apart, which is not a good thing. So we're going to go ahead and see why that's happening. So we'll flip back over to the assembly that we brought in, and you may or may not know that when you bring in assembly files from other CAD systems, they don't come into Solid Edge with the same intelligence that they had from their original CAD system. So it doesn't know or recognize mating conditions or alignments, for example. So they come in relative to their positions, but not with the intelligence that they should have. So you'll see here that we've got, if I select any of these components, they're just brought in with what we call a grounded component. Well, for my purposes, I need the intelligence applied back into the assembly. So Solid Edge has a really nice tool that allows us to do this very quickly and very easily. I'm going to select all the components inside of my assembly, and we have this nice tool called Assembly Relationship Assistant. When I go to that tool, I'm going to just start off by saying let's remove all of the what we call dumb relationships for that assembly. Now as soon as I do that, Solid Edge will give me the option to now place intelligent relationships between the parts that I had selected. So I can do mating conditions, planar alignments. If there are any parts that I want to align but also allow offsets, I can do that. And then axial alignments, for example, where the bolt goes into a hole. Now I don't want to do the entire assembly at one time. I could choose to do that if I wanted to, but in this case I want to have a little bit more interaction. So I'm just going to close that. And if we look over here on the Pathfinder, you'll see that all those grounded relationships have been removed. Now I'm going to break this up a little bit and do this with, like I said, a little bit more interaction. Let's focus first on the bearings. So I want to utilize that same tool, Assembly Relationship Assistant, and you'll see here that I've actually placed that on my radial menu so I can get quicker access to it. And what I want to do is look at the bearings relative to the housing that they're in. So really, there's, as I mentioned, 6 bearings into the housing. There really aren't any mating conditions, but we do want to make sure that the face here of our bearing is flush with the face of our housing. We want to make sure that they stay aligned inside of the boss. So as soon as I click Process, that quickly it found all of those different relationships. And if I'm not mistaken, it has found 12 relationships in a matter of a second. So if I highlight a component and then highlight the assembly relationship that it found, you'll see that it finds axial alignments and it gives us feedback over exactly what it has found. If I don't want it to apply any of these relationships, I just simply uncheck the box. If I want to accept all of them, I just hit accept, and now it has all of those relationships applied between those components. I'll do something similar with some of the other parts. So in this case, I want to select the bolt or the screw, this connecting arm, and then maybe the nut here. This time I do want mating conditions because the screw head is going to be mated to the outside component here, and then I also obviously want to keep some of the others. But again, instantaneously it finds all those relationships for us. I'll accept those. Now if I highlight any of these components, you'll see down here all of these intelligent relationships that were applied in just a matter of seconds. If you were working with other CAD systems, this process here is manual and it's much more tedious. In Solid Edge, it's instantaneous, saves you a lot of time. Now you can also utilize standard assembly tools. So if I wanted to just manually start assembling components, I can do that also. So maybe I want to make sure that these components are lined up, but maybe I also want to make sure that they stay centered. So we can utilize this nice handy center plane relationship and say, let's keep these two faces centered about those two faces. Okay. Now the other thing that I want to draw your attention to is even after they're applied, you still have full control over them. So as an example, if I select that bearing, and look, we see that it again has a planar alignment and an axial alignment that the Relationship Assistant tool applied for us. If I wanted to modify the alignment and maybe push that bearing in slightly, I can type in a specific offset value right down here, or if I want to make it flush again, I can go ahead and put it back at a 0 offset and put it right back where it was. But it's just to show you that you have full control over these relationships. Same thing here for this screw. You'll see that the screw has a relationship with part 501, an axial relationship. If I wanted to modify what part it is related to, I can change that with this nice handy quick bar up here and say, no, let's align it to this component instead, and that quickly it allows me to change that, and now you'll see that it is aligned with part 502 versus 501. Okay, well, let's go ahead and save what we've done up to this point, and let's go back to our top level assembly. So now let's go back and try to validate our mechanism and make sure that it's working as it should. Again, we did this in just a matter of a couple minutes. So now as we go ahead and check the validity of our mechanism, let's go ahead and move the shock. And now you'll see everything is working as it should. Our parts are staying together. We can check, let's see, the minimum stroke of our shock. Everything looks good there. Let's go ahead and maybe push it out to its maximum stroke. And actually, as we push that out to its maximum stroke, we do have some issues here. So we may need to make some design changes to our mechanism because of the interference that we're seeing here. So let's take this back to its original position, and let's see what we can do here. Let's go back to our mechanism. Alright, so now that we're working back in the subassembly for the mechanism that we brought in again from, in our example here, SolidWorks, what can we do to make some design changes? Now we can study the mechanism, figure out exactly what we need to do. And the other thing that we want to point out here is the flexibility that Solid Edge gives us in making design changes. So Solid Edge does a really nice job of doing what a lot of CAD systems do, is they allow you to go into the part itself to make design changes, and we're going to do that. But we'll see here in just a little bit that Solid Edge will actually allow you to make design changes to a part at the assembly level. So we'll show you all of that. But I want to go ahead and start off with what is common to a lot of engineers is I need to make a design change, let's say to this housing. I'm going to go into that housing component. We'll look at that part all by itself, and we'll figure out what we need to do to make changes to this. What I also want to do in this example is I want to compare and contrast the differences and or similarities between how Solid Edge handles design changes with data that's imported and how those other guys make changes to data that they import. Okay, so let's go through an example first of how the other guys or the other CAD systems make changes to imported data. So as we look up here at the top of the screen, we have these commands here called move faces, rotate faces, things of that nature. And what a lot of the other CAD systems out there claim that they're able to do is work directly with 3D models. And that's true to some extent, but they're very limited in the types of direct interaction that they have when they import data into their systems. They can do very simple move faces. They're very simple, very rudimentary, but there isn't anything that they can do that's more on the side of complexity, I should say. So let's go through an example of what they might be able to do. So let's say, as an example, that we've decided that we need to change the spread distance between these two holes. Now, if I were working with another CAD system, what they would have to do is they would have to go to a move face command or something similar, and they would go through and say, okay, well, I want to move this hole, or I want to move this boss. So if they select the boss, as an example, they can say, I want to move that boss in this direction. And as they go to move it, it will do exactly what they told it to do. It's going to move the boss, but notice there's no intelligence. It doesn't know that the hole needs to move with the boss. So it's just moving exactly what the user selected. Okay, so since it's not moving the hole with it, I may, if I'm utilizing that other CAD tool, I may have to select both the boss and the hole. So let's see how that works. Okay, that's a little bit better. It's moving both of them now since I selected both, but it's not actually moving that angled face for me. It doesn't know to stay tangent to the angled face. So, all right, what might I need to do then? So if I go to move faces again, we'll select the boss and the hole, and let's go maybe and select some of these angled faces. Let's see what the result is now that I've actually selected what I want to move. Again, we want to move this up, so we'll pick the direction. Okay, that's a little bit better, but still not exactly what I'm looking for. It's running into some limitations here. It's not doing anything with the boss in the middle. All right, so maybe as one last stab, maybe one last attempt at this, let's just maybe do a window selection. I want to move all these faces up. Okay, so we'll move it in this direction. Okay, it almost looks like it's going to do what we want, but again, it's not quite doing exactly what we want, and we're running into some limitations. It's not allowing us to do what we want. And this is a common scenario when you're working with other CAD systems besides Solid Edge, and they want to work directly with a 3D model and make changes. Very, very limited in what they're able to do. As a secondary example, let's say, for example, they want to widen the boss. So again, if we utilize that rudimentary move face command and we pick that face, notice it'll move that face. It'll do exactly what we told it to do, but again, the design intent is for the boss to stay symmetric, but notice it doesn't know, there's no intelligence with these tools that keep the boss symmetric. So if I were going to change the width of the boss, let's say widen it by 12 millimeters overall, I would have to move this out 6 millimeters and then repeat that same process on the other side in order to keep it symmetric. The other thing that I want to draw your attention to, the limitations that the other CAD systems have, is it didn't recognize that these bosses are all the same size, and if I want to change one boss, I may want to change the other two bosses at the same time. So if I wanted to change the other two bosses, I would have to repeat that process again for the other bosses. Again, it doesn't do that in one command or one step for me. And then finally, another limitation that some of the other CAD tools have is they may claim that they're able to put 3D dimensions on the model. So they would come in and maybe place a dimension between these faces here. The difference, though, is while they can place a dimension for visualization, they can't do anything with the dimension. I can't change this dimension and make modifications to the geometry. It's only there for visual purposes. Okay, so let's see how Solid Edge handles the same type of situation. So let's undo everything that we've done up to this point. Let's undo the move faces and the dimension, and let's go into Solid Edge and let's show you what Solid Edge with synchronous technology is able to do. So the first thing that I want to do is we mentioned that we want to make some design changes. We want to change the spread distance between these two holes. In Solid Edge, I can pick the hole or I can pick the boss. Doesn't matter which one I select. Solid Edge automatically knows with what we call design intent that when I pick that one face, it knows to move corresponding faces of the part, assuming that I want to maintain my design intent. So what exactly does this mean? Well, what it knows within this part is it knows that those two holes are symmetric with each other. If I'm moving one hole, I probably want to move the other hole in order to maintain that symmetry. Notice also that it knows to move the tangent faces. I don't have to select those individually, but I can select that one boss or that one hole, and it's going to move the tangent faces for me automatically. In a similar fashion, if I wanted to utilize the other example we talked about, if I wanted to widen the boss a little bit, if I select one face, notice that it's going to move all three bosses at the same time. Again, if we look at our design intent field or window, it again knows that the part has symmetry to it, so it wants to maintain that symmetry. And it's also finding what we call coplanar relationships, meaning the bosses are the same size. If you want to move one boss or change one boss, let's assume you're going to want to change all three bosses. The beauty of the design intent window is, as the user, I have full control over that. So if I wanted to turn off the coplanar option, again, I just uncheck that box, I can move just the one boss and not affect the other two. If we go back to that original example and just show how we can utilize the design intent, you saw before when I moved the boss, it was moving the other hole at the same time. If I turn off symmetry in this case, I can just move what I selected and not affect the other hole in this regard as well. So just to reiterate, the direct interaction that Solid Edge has with the 3D model, it comes with built-in intelligence in the form of our design intent window. So we talked a little bit about just the direct interaction where we push or pull the faces and adjust the model that way. But what about typical design engineers who like to make precise modeling changes? And in order to do that, you typically want to have a dimension on the model. So we saw that other CAD systems can place 3D dimensions on the model, but they can't really do anything with them. And that's not the case in Solid Edge. With Solid Edge, if I wanted to place a dimension on the model, I simply just place the dimension. And with that dimension, again, I can choose to modify the dimension and change the spread distance symmetrically. Or if I turn symmetry off, I can just move the hole in the top. Or what's nice about our handy dimensioning tool is if I change the direction of the dimension, as opposed to moving the top hole, if I wanted to move the bottom hole instead, I have full control. So there are actually 3 different results that I can get based on my interaction with the model. If symmetry is turned on and I change the dimension, I move both holes at the same time. If symmetry is turned off, I can choose to move the top hole or the bottom hole based on which option I select in my dimensioning toolbar. So again, great flexibility in making design changes. The other thing too that I want to draw your attention to is we also give you the ability within Solid Edge to add in your own design intent. So for example, in the other CAD systems, if they wanted to apply constraints to their model, they have to do that with sketch constraints. So and many of us today who are used to utilizing CAD systems where you draw a sketch first and then you apply the third dimension, in your 2D sketches you apply your constraints and your dimensions there. Well, in Solid Edge we have the ability to do that directly on the 3D model. So for example, maybe I want to keep the wall thicknesses parallel and offset from this back face here, and we can do that with what we call an offset relationship. And I want to keep that offset at 4 millimeters. And I'll go ahead and repeat that same process for the wall thicknesses down here at the bottom. So again, I just simply select those two faces, Tell Solid Edge to keep those offset at 4 millimeters, and you'll notice that is applied over here in my Pathfinder, so I can see exactly the type of design intent that I've added into this part model. So now as I start to change the dimension, you'll notice I can modify this. Now, as I mentioned before, we want to change the spread distance. Let's maybe change it to 75, and we'll change it to that value from 60, which is the original value. Let's add some other dimensions here that we may or may not need to change. Let's go through and maybe add a dimension here. Maybe we've also determined that we want to maybe push that middle boss out some value, maybe 10 more millimeters out. We'll place a dimension maybe vertically as well. Maybe we want to push that middle boss down just a little bit, maybe change it from 38 to 35. And then just to show that we'll place a dimension in a different orientation or a different plane, let's select the two edges of our boss here. And again, if I wanted to change that value, I could do that. And again, I can change all three bosses at the same time with that dimension. Or if I just wanted to change just the one, I can turn off the coplanar relationship and just change the one by itself. So again, great flexibility with placing dimensions on the 3D component and making whatever design changes I need to make. Let's just wrap up the changes that we need to make by maybe rounding some of these sharp edges. So we'll round all of the edges except for maybe the inside of the hole. So let's just deselect those. Maybe on the interior of the holes we'll just place or maybe on the edges of the holes we'll place some chamfers here. So that will complete the design changes that we needed to make to this part. And again, just like we've done with other CAD systems, if we wanted to make changes to a single part, Solid Edge gives us great tools that allow us to do this very quickly and very flexibly. So we'll save what we've done, and we'll come back out to our subassembly. Now, again, you'll notice with the changes that we made to this housing component, our bearings have updated to their new position, so they've stayed aligned with the bosses within our housing. So we'll save that. And then if we wanted to do a quick check up in our top level assembly, those changes are reflected here. So again, talking about making changes at any level, we made the changes in the individual part. Those were reflected in the subassembly, and then those are also reflected back up to the top here in the top level. Okay, let's go back to the subassembly for just a second. We've also determined that we need to make some other changes, maybe in this case to the connecting arm. So this time we're going to make changes instead of at the individual part level. Let's make changes here at the assembly level. So let's say we've determined that we want to make some changes to the holes within our part. What's nice about Solid Edge is we have tools that allow you to add intelligence back into the part model with different parameters. Now when you think about holes have different types of parameters based on what type of hole it is. If it's a simple hole, it may just have the diameter. If it's a counterbore hole, it may have a number of other parameters. So in Solid Edge, what's nice about this is even when I'm working within the assembly file, I can tell Solid Edge to recognize the holes in this part. And it'll say, okay, well these are, or they appear to be counterbore holes. And if I go into my hole options, if I wanted to change the type of hole that it is, maybe from a counterbore to a simple hole, I can go ahead and change the type of hole that it is. If my company utilizes a specific standard, I can choose the standard and then get access to other options here. In this case, I just want to change it maybe to a simple hole and change the diameter to a 12 millimeter diameter. And as soon as I click OK, Solid Edge will automatically change the hole type right here at the assembly level. Now let's go into the part just for a second. Let's look at and see what that did. So what you'll notice here is Solid Edge went ahead and added in parametric holes into this imported part. So I can click on the hole here. If I click on the dimension, I have access to change the diameter from here, or I can go back in and change any of the other parameters associated with that type of hole. The beauty of this, again, is if I come back out to my assembly, I can also do that from the assembly, just by simply selecting the hole, and I can again make that change right here at the assembly level. So you can pick and choose wherever that's most convenient to make that change. If you don't want to go down into the part to do that, you can do that right here from the assembly. In a similar fashion, we have also a tool here called Recognize Chamfers. So maybe I want to recognize these as actual chamfer features, because currently they are not. So again, if I click on that part, Solid Edge will come back and say, okay, I recognize that you have a chamfer on the top side as well as the underside of this part. And while I'm in this dialog, if I wanted to change the type, or I'm sorry, the value of the chamfer, I can do that and modify it right from here. Again, if we go into the part by itself and see what Solid Edge does for us, is it's added in a smart feature or the intelligence into the part. So again, I can make that change from here. It recognizes that chamfer. I can change the value. Or if I were in at the assembly level, I can recognize that chamfer from here as well and make changes right here at the assembly. Finally, maybe some other changes we need to make to this component is maybe for added strength, I want to remove this cutout. Again, this is an imported part. I don't have an actual cutout feature, but Solid Edge does have a tool here called Selection Manager, and if I select any face of that cutout, Solid Edge will give me the ability to recognize that cutout from here, and it'll go through and select all the faces of that cutout so that I don't have to do that. And then if I want to delete that, I just hit the delete key and that removes all that geometry for me. So it allows me to make a very quick change to this part in a matter of seconds. Let's save everything that we've done. And again, if I wanted to go back into this part and do anything with this particular part component, if I wanted to, just like I did with the housing, if I wanted to come in and add any dimensions to this part, maybe make some changes to the width of that ear as an example, or maybe 9 millimeters in this case is okay. I'll leave it at 9 millimeters. Or maybe I may determine that somewhere down the line we may need to make some changes to the spread distance between these two holes. So you can come in and add as many dimensions to this as you want to, and then make changes to this component via those dimensions, just like what we saw earlier. Let's save everything that we've done up to this point. So again, if I go back up to the top level assembly, again, you'll see that those changes are reflected here. Alright, so now let's look at this top level assembly. We're at the top level. I think we saw earlier when we first brought this component in and assembled it that we've got some interference back here between this component here, this connecting arm, and our swing arm here in the back. Well, if you'll recall, we didn't really put any dimensions or any information into the part here while we were working in that part level. And with Solid Edge, that's okay because you don't have to do it while you're at the part level. So let's see, first off, what is the distance between these two faces? And it looks like it's 50 millimeters. What's nice about Solid Edge, and before we make any changes, I'm just going to hide a couple of components here. Let's maybe hide the tire as well as some other components. Let's just clear the area so we can get a little bit better feel here for what we're looking at. What's nice about Solid Edge is I'm working here at the top level assembly, and I can go into my dimensioning commands, and Solid Edge has this nice feature here called Create and Model. Create and Model will allow me to place a dimension on a part that gets filtered into the model itself. So we saw down here that the distance where this part's connected to is 50 millimeters. And what I want to do is I want to change the spread distance to, let's maybe give it a little bit of clearance in there. Let's change it to 52. And I can make design changes to a part right here at the assembly level. Now by doing that, you'll notice that we've created quite a bit of extra slop, I guess, in between these components. And now I may want to go through and maybe change the width of this boss. So again, right here from the top level assembly, I'm going to change this from part priority to face priority. And when I do that, when I select on any face of this part, it'll pull up any dimensions that I've applied to that part. And I may want to change the width of the boss right here at the assembly level. Now if you recall, when we were working on the housing earlier, when I changed the width of one boss, it changed all three at the same time. Well, if I try to do that in this example, we'll run into interference with our clevis up here for our shock, and then we'll run into some interference as well down here with our frame. So I get the same design intent options here, and what I'll do is I'll just turn off coplanar, and what I'll do is I'll change this from, let's say, 25 to maybe 48. And again, I can change that value and change this part right here from the very top level. Now if we go back into the subassembly, that change is reflected here. And if we look at this part by itself, that change is reflected there as well. So unlike when we made changes originally to this housing, when we made it at the part level and those changes filtered up, we just essentially did the opposite, where we were at the very top level, made a change from here, and those changes filtered down to the part. So it's very flexible when you're working with Solid Edge and you want to make design changes. And remember, this is all imported data that came from another CAD file system. Maybe one last check here is we'll just to be on the safe side, let's select this component again. Let's maybe change the spread distance just a little bit. Let's change it from 75 to 85. And then one more time, let's maybe check and validate that this mechanism is going to work as it was intended. So again, as we go to the minimum stroke, we've got no issues there. Let's extend this out to the maximum stroke. And visually I may not be able to tell for sure if we got any interference, and that's where this nice handy tool called Check Interference comes into play. We'll just select these parts and verify that there are no interferences when that shock is extended to its maximum stroke. So we've made all the necessary design changes that we need to make, which is good. Maybe just to finish off our design, we will come and maybe add the remaining fastener system that connects our connecting arm to our swing arm. So we'll go through and select this hole here, and we know it's going to be coming through to the back side. And this will bring up the Solid Edge standard parts components, and again we changed that hole type to a 12 millimeter through hole earlier in our design process. And what Solid Edge will do is it will go out to our standard part components and it will find for us the fasteners that would fit inside of that size component or that size hole. So this will pull up, and again we'll select, in this particular case, let's go through and find, let's see, the hexagon socket head cap screw. We'll find the DIN standard here, and we'll select that one. And then we'll go and select, maybe for the bottom stack, we'll maybe find a nut that we want to utilize. And that will fasten those two components together. And then just to match up the same look and feel, let's go ahead and change the finish of our components here to a more chrome style. So I hope you found this particular example beneficial and useful for maybe some things that you may want to do with your designs when you're working with imported data. I'm going to wrap up the presentation by showing you some alternative methods of working with imported data. I'm going to come back to the original files as they were before we added any intelligence with assembly constraints or any intelligence back into the individual part models. So if we go back and look at the relationships for the assembly, you'll see that they are still grounded. and there's no intelligence in any of the parts. So again, if I go back and look at any of the parts, they're just simple body features. So some alternative ways that you can work with the data is to just again make changes to multiple components all at the same time. We focus more on individual parts and then sub-assemblies, and but we didn't really change too many parts at the same time, which is another great benefit that Solid Edge has when working with synchronous technology applications. So if we look at the changes that we made earlier, if we wanted to apply some similar changes here, one thing that we can do while working at the assembly level is I can come in, for example, and find either full or complete sub-assemblies. So maybe as an example, if I find this entire bearing, if you look at my cursor, I have a little orangish yellowish box next to it, and that's what we call part priority mode. And without doing anything in terms of assembly constraints or adding anything to the parts themselves, I can select individual assemblies, or I can also, I can also select individual faces of multiple components. So up here in your select application, there's also face priority, or I can get to that also with a control spacebar selection, and you'll see that my icon changes next to my cursor. So I can go through and I can select, for example, individual faces. So as an example, I'm going to come through, just window select around this area of my assembly. And if we look closely, you'll see that I've selected portions of the screw. I've selected different areas of the connecting arm. I'll also select maybe this individual face for the housing component. And then I'm going to switch this back to part priority, and let's go ahead and select that entire bearing. And let's look at this more from a top view. Let's rotate this around this way. And with all of that information selected, again, I can utilize my steering wheel tool and simply say, let's maybe spread these components out, let's make changes to it. And you'll notice that as I'm selecting the steering wheel, I can drag all of these components and make changes to all of them at the same time. Now if you again look in your design intent field, you'll notice it's changing all three bosses at the same time. I may only want to change the one in the middle, so I'm going to turn off the planar alignment so that it leaves the top and bottom bosses to their original width, and I'm just going to change the one there in the middle. So if we wanted to change the overall width of our connecting arm there in the middle, we'll go ahead and just put 6 in. That'll be 12 total since it's changing it symmetrically. So again, just to reiterate, we just moved the bearing here that we selected on the interior. We just made the spread distance change on the connecting arm. We widened the boss, and then we also lengthened the screw all at the same time. Very, very powerful to do that inside of Solid Edge. Now let's draw your attention to what we did not do yet. So as an example, you'll notice my nut, because we don't have any assembly relationships tied back into the assembly yet, it just stayed where it was. Same thing with the bearing here on the opposite side. It just stayed in its original location. And I want to draw your attention to something. Let's go find those in the Pathfinder. So it looks like the bearing is the first option here. And if we look at its assembly relationships, you'll notice that it's still grounded. And then let's do the same thing for the nut. It's also still grounded. But what's nice about this is if I select the bearing and then come over also and select the nut, you'll notice we have in our quick bar application, we have this option here where we can tell Solid Edge, very similar to the assembly relationship assistant, we can have Solid Edge, by utilizing the steering wheel tool, as we move or copy components, we can have it automatically place assembly relations as those new parts are placed in their new location. There's different options here that you can investigate. The one I've selected is, I'm saying remove all the external relationships and add new relationships to other components. What this will do is, as I move these parts, it will remove the grounded relationship automatically, And wherever I place or stop the movement, it will look around those components that I'm moving, and it will find mating conditions, alignments, things of that nature. So just for clarity, I'm going to move the steering wheel out here to the outside for a second. And what we're going to do is we're going to move those parts 6 millimeters, this time in the opposite direction. So let's come out here and we'll move those 6. And what Solid Edge is prompting us for is select the parts that we want to constrain the parts that we just moved to. Well, in this case, the nut is constrained to the connecting arm. We know the bearing is going to be constrained to the housing. I simply select those components, and what Solid Edge does for me automatically is now when I select the nut, you can see that it has alignments, mating conditions. Same thing here with the bearing. It also took out the grounded relationship and applied those relationships automatically for us. So very, again, intelligent tools as we're just moving parts around to their new location. In a similar fashion, let's make some other similar changes that we did before as well. So this time I'm going to move, let's see, this bearing here, which is bearing number 6. We'll also select this bearing on the other side, which is bearing number 3. And then we'll select this face of the housing. We're going to turn symmetry off because all we want to do is move upwards. Maybe change that by maybe like 10 millimeters or so. And again, we're going to move this up. And you'll notice it's doing exactly what we tell it. So we'll type in 10. Again, it's prompting us because those bearings moved. How do we want to assemble those? We want to assemble them to the housing. We accept. And now if we look at those components, they have automatically applied planar and axial alignments. So we can make very quick changes just by utilizing the steering wheel tool and having the parts update and apply the assembly relationships all at the same time. The last thing that you'll notice too is right here at the assembly level, we can also apply those face relationships. So if I wanted to apply the proper thickness to these ribs, I simply just pick the faces, very similar to what we did earlier, and then I just apply what that thickness should be, in this case 4 millimeters. And we can adjust that part right here at the assembly level. So again, I wanted to just show you some alternative means of making the same types of changes we did earlier without necessarily going in and applying all of the different intelligence factors that we did before. This is more directly editing the components but still applying different pieces of intelligence back into the models. Finally, I wanted to show you a really quick tip on how you can utilize legacy data that's in 2D format. We talked in the beginning of the presentation about companies that have legacy data, whether it's 3D or 2D, and in some cases it may be a combination of the two. Whether it's 2D data that was created from scratch in a program like AutoCAD, or maybe in a previous CAD system you had associated 2D drawings that were created from the 3D models. What I wanted to show you here is in the case where you might want to reuse not only the 3D data but also the 2D documentation of that 3D data together. I'm going to show you a real quick tip on how to do that. Again, if we go to our just standard file open dialog and change our files of type here to, in this case, DWG or DXF, if you do have legacy data from a previous 3D CAD system, what you can do is take the 2D drawing information, save it out as a DXF or a DWG file format, open that up inside of Solid Edge directly, and what you can do is marry the data that we find here to the existing 3D model. So we saw before when I open up a 3D model that came from another CAD system, again it's just a simple body feature with no intelligence unless we go through and manually apply that. You saw earlier how we went through, opened up the 3D model of this housing component, we added the dimensions that we wanted to manually. What we could do is if we wanted to take the manufacturing information off of this 2D drawing and place it on the 3D model automatically, this is how we do that. So inside of Solid Edge, we have a tool here called Create 3D. Now if we didn't have a 3D model already, we could utilize the information here in the 2D drawing to create a 3D model from scratch. If we have the existing 3D model, what we have the ability to do is take that and the information from the drawing and essentially place it into the 3D model in a very automated fashion. So here in the wizard for the Create 3D tool, I just simply select the imported 3D model file, and as I go through the wizard, it's going to prompt me for what information I'd like to apply to it. So I just simply window select around, in this case, the front view. We'll come over here to the side view as well. And we're going to fold these two drawing views right down the middle here, and as soon as I click Finish, what's going to happen is Solid Edge will automatically copy and paste the drawing information that we found in the drawing, line those up automatically into the 3D model views, and then what we have the ability to do with this information is simply tell Solid Edge to attach the 2D manufacturing information to the model via this Attach PMI option. When I do that, it simply takes all those dimensional information that we just copied and pasted through that wizard and attaches it automatically to the solid model. Now you'll notice here that it took the sketch information as well, and just to prove we really don't need the sketch information anymore, I'm simply going to delete that from the file here, and you'll see that the dimensions still stay attached to the model. And these should look very familiar to the ones that we placed, a few more than what we placed earlier, but again, the same application still applies. I can simply select the dimension and drive the geometry right from here. And this is another way that we can reuse information without having to manually apply it and make very fast, flexible edits to it. This will conclude the presentation for Design Without Boundaries in a Multi-CAD World. Again, my name is Kevin Grayson. In addition to working with your local partner or Solid Edge reseller, please feel free to contact me at the information listed here if you have any questions about this presentation or any general questions about Solid Edge. Solid Edge, design better.